Today we're gonna do a test-driven development using C#, Visual Studio Code, and .NET 5. So we're going to do TDD on a very simple coding exercise called FizzBuzz. So why do we need to do TDD on such very simple coding exercise? So for one, if you're doing some coding interview, then your interviewer, let's say, knows about TDD and the importance of testing, then that's a good point for you. Otherwise, if he or she doesn't know about TDD, it's still good because you know that your code works. You have confidence that your code works. And that's really a good indicator that you will be hired, right? So as we know, test-driven development cycle involves red-green refactor. So red means we were going to write a failing test first, and then we go to the next phase or the next step, which is green, trying to create or write enough code to make the failing test pass. And then go to the refactor step just to change the structure of our code without changing the functionality, and then go back to the red again, completing the loop. So we will do the FizzBuzz exercise as I mentioned, and also we're going to use Visual Studio Code. So if you don't have that, you could download it from here. You can download on whichever platform you're using. And also we need the .NET Code 5. So this is actually the successor of .NET Core 3.1. So it's also cross-platform. So it would work on Linux, Windows, or Mac OS, just like I have right now. Alright, so let's proceed with our coding or setup. Let me open my terminal, and here let's first create the main folder or directory where we will put all our code. So let's call it FizzBuzz, and then go inside that directory. So to make sure that you have the .NET CLI, you can do it like this. You can check it like this, .NET -- version. And then, so if you verify that you have the version 5, then it's good. And then the next thing we need to do is to create our system under test. So since this is a very simple program, we will use a console application. So let's create that console application by typing in .NET new console, and then let's put the output files inside the directory called FizzBuzz. .NET will create the projects for us after a few seconds. Alright, and then we will also create the test project. We will use NUnit, so .NET new space NUnit, and then let's put the output directory to FizzBuzz.test. Okay, that was quick. So now we have two directories inside our FizzBuzz directory. One for the system under test, the FizzBuzz directory, and the other one is the test project. So right now they are, even though they are on the same folder, they are not related. So we need to add the reference to the FizzBuzz.test to the system under test. So to do that, let's go inside the FizzBuzz.test directory, and then add the reference. We go up to the main folder, and then let's look for FizzBuzz.csproj. Okay, so that should do it. So let's see if we got everything correct. So let's run .NET test. So when we created the test project, it has one sample test there. that's always passing. So if we see this, then everything's good. Okay, so we go up one directory and then time to open up Visual Studio Code. So that's the shortcut to open the current directory to Visual Studio. If you don't have that, then it's okay. You can just manually open it by first opening Visual Studio Code and then opening that folder. Alright, so as I mentioned, we have a sample unit test here that is always passing. We already saw that it passed, but let's open up a terminal here. If this pop-up shows up in your screen, just press yes. It's just asking which project you want to launch and how to launch it when you're debugging. We will use this later on. Okay, so let's go inside FizzBuzz.test and then .NET test. Should still pass. Okay, so next step, we will create a file here called the instructions.md. We will paste in here the instructions for FizzBuzz so that we can refer to it as we move along. I'll just paste it in. Okay, so we need to write a program that prints the numbers from 1 to 100, but for multiples of 3, print Fizz instead of the number, and for the multiples of 5, print Buzz. For numbers which are multiples of both 3 and 5, we're going to print FizzBuzz. Alright, so now we're going to write our first failing test. We need to print the numbers 1 to 100. That means we could create a generator class, which of course doesn't exist yet, and then we will store the results in a results variable, which coming from the generate method. Of course, this is considered failing test because it doesn't even compile, so we need to generate the generator class. So to do that, just click that within that squiggly line, generator class, and then let's generate the generator class. So at first, within our unit test file as well, let's change this to public, and then let's generate the method as well. Okay, so let's change this to public. Let's remove this error throwing there, and then let's fix this. So we need to return something. Just to make it pass, let's say we will return null. Okay, so now it compiles. There's no more red warnings here, or red errors, but it doesn't test anything. So let's create our first test. So let's assert that the results have 100 items in it. Count. So we were going to use list instead of array just to implement it differently. So that means we should return an list of int, which we need to import or add the using statement above, using system.collections.generic. Okay, then let's put the missing semicolon there, and then let's see if this will fail. We need this to fail. We are on the red step right now. Yes. Okay, so now we need to make it pass. So should be easy. We create a variable called results, which is initialized to have a list of int, and then we will create a for loop of 100 items, and then for each iteration, let's add I plus 1, since we are dealing with the zero base index here, so we need to add plus 1 and then return the results. Okay, so let's see if this will pass. It does. Okay, so now we are on the refactor step. Do we need to refactor anything here? Perhaps we just need to rename this variable result is too generic, so perhaps numbers or items. And what else? We need also to refactor our tests as well. Let's change this test1 to a more appropriate name. So should generate 100 items. And then let's see if this still passes. It does. Okay, so you might notice that we are constantly typing in .NET tests for each changes that we make here. Actually, one thing that we can do that to improve that is to use .NET Watch test. .NET CLI will automatically compile and build our projects and then run the test for us. So what else we need to refactor? Our generator class is inside our unit test class here. So we could also rename our class to be FizzBuzz or generator test instead. And then let's see if we could ask Visual Studio Code to rename this for us. So the way to do that in Mac is command dot, and then we could rename the file to generator test.cs. Okay, so as you can see here, it's automatically running the test after we change. And then we also need to move this outside this class, so command dot. You can check out what's the keyboard shortcut for Windows. So we need to move type to generator.cs. Okay, so we save this and this generator test and the actual generator class. Okay, still passing. So now we need to move this generator.cs class to our other project folder. So let's just drag it there and then fix the namespace. Okay, fixing the namespace. I don't think we need to do anything else here. It's still working, I guess. Yes, all right. So now we move on to the next case. So we need to create or write a failing test again. So for the multiples of 3, we need to print Fizz instead of the number. So you might already notice that there's a problem with our generator class because it's generating a list of int. So we need this to generate a list of strings to accommodate the word Fizz. So we should create a new test method here. Should return string, let's say. Let's decorate this with test, so NUnit knows that this can be run. Alright, so let's just copy this, put it here. Code smell, we'll fix that later. Assert are equal. So let's just assert that the first item in the list is number 1, is the string number 1. So results 0, that's the first item. Okay, so let's test. Should fail. Yep, we are expecting a string 1, but we got a numeric 1. So to fix that, we need to change the return of generate here to string, the return type, to list of string instead. So let's fix this. Convert it to string before adding it to the list. Then let's see if this will pass. Alright. Of course, that's not the instruction we got here. We just needed to convert the list to string. So let's deal with this case now. Let's create a failing test. The simplest failing test we could create is the multiples of 3, which is 3. The first multiple of 3 is 3. So let's say the third item, which is 3, should be Fizz. Okay. Okay, I forgot to refactor the duplicate code there. So let's go to that after we make this pass. We will do that after we make this pass. Alright, so we expect the third item, which is on index 2, to equal Fizz. That's the third item. So expected Fizz, but was 3, so yeah, failing test. We make it work by adding a condition here. So if I plus 1 is equals 3, that means the third item, then instead of adding the number, we will add Fizz. It's almost like cheating, but believe me that this is the way to do it, so that we could understand how our code works. So now we can see that it passes, but it won't pass if we say that the sixth item, that's on index number 5, because we just basically hard-coded it here. So we could do it like this. And make it pass, but we know that it won't work for 9 and for the succeeding multiples of 3. So yeah, so right now let's refactor first. So since we have a green here, successful test or passing test, so let's refactor some of these duplicate codes. So you can notice that we are always calling in generate method, so we could move this inside our setup. And setup, we could move outside. So we could say private list of string results. Let's bring in the missing using statement there. Then we don't need to to declare new variable. We are just using that private field. We could get rid of that and this one as well. So this should still pass. Okay. So next item, let's put it back to 2 so it would match the name here. Let's write a fading test. The 9th item should be is just copy that assert statement and then test if the 9th item is Fizz. Okay, so now we know that we could not do this forever until the 100 items because this is not the correct implementation. So what we could do is to test if the current item is a multiple of 3. So to do that, we will going to use modulo operator, the modulo operator. So I plus 1 modulo 3 is equals 0. So modulo operator is taking the remainder after the division. So if there's no remainder, that means this item is a multiple of 3. Otherwise, we just print in the number or add in the number. We expect this to pass, but it didn't because the number 3 where we are seeing some failure here. If I plus 1 is 3. Alright, so this is a classic mathematical issue or bug that we need to group this first. I plus 1 before running the modulo operator. Then it should pass. Alright, so time to refactor. So you might notice these are starting to be redundant, so we need to extract this to a variable. So let's take this and move it up. Let's just say this is the item I plus 1, and then we could replace this with the item and this with the item. Should still pass. Alright, so next test that we could write, we could remove this test. So this is normal. Sometimes we create test just to remove it later, and we can also remove this supporting test to make our test suite clean. It served its purpose already. The next is multiples of 5. So let's create 5th item should be buzz assert are equal buzz results. The 5th item, then it's annotated with test. Let's see if this will fail. Yes, indeed. Okay, so let's make it pass. So after we tested for multiples of 3, we could put an else statement here to see if the item is a multiple of 5. If it is, then we should add buzz instead. And it should work. Alright, it did work. Okay, so we could also create several tests for multiples of 5 just to make sure, but we know that it would work since this is already tested by Microsoft. The modulo operator is native operator in .NET framework, so we don't need to do that. So let's proceed with the next case we have here. For the numbers which are multiples of both 3 and 5, we print FizzBuzz. But before we do that, let's see if we could refactor something here. I guess we're still okay. So we create our next test case. So what is the first number in the sequence of 1 to 100 which is both multiples of 3 and 5? So it's 15. So 15 item should be FizzBuzz. Okay, let's assert that the 15th item should be equal to FizzBuzz. And this should fail. We are on the red phase right now, so it should. So what we can do here is above the first if statement here, we need to check if it is both multiple of 3 and multiple of 5. We need to put it here because we need the two conditions combined. So if the item divides evenly with 3 and divides evenly with 5, then we will add the item FizzBuzz. Otherwise, let's check for the other conditions. Let's see if that will make it pass. It does. So what are the refactoring that we need to do here? First of all, I think this method is starting to get longer, mainly because of the optional curly braces. It's optional if we only have one statement after the if or else statements. So that significantly reduces the line of items. Also, I'm not a fan of the curly brace on the next line, except for the main method. But my IDE is formatting it that way, so let's leave it as is. What else do we need to do to refactor here? We have code duplication. This and this are duplicates. To refactor this, we need to extract a method. Extract method. And then let's call this method is multiple of 3. Let's rename the new method to be is multiple of 3. Yes, it still passes. Let's replace also this one and extract this as well. Is multiple of 5. Okay, so let's replace also this with our new method. Alright, so that should do it. We could even go further by using the C# feature called extension methods. So instead of writing it like this, we could write it like item dot is multiple of 3 or is multiple of 5. So it's a bit more natural to read, but I leave it up to you as an exercise to do that. So one of the most important benefit of TDD and having our code covered with unit tests is we're not afraid to change our code. We could refactor this even further without fearing that our changes would break our code. So since we are covered with unit tests. So I guess we already covered everything. We're done. So the last thing we need to do is to print the numbers. So right now we are just testing for each case. We could move on or go on testing for other cases as well. So let's add here the next multiple of both 3 and 5 is 45. So that's on index 44. Okay. So we could also use the NUnit feature in the text fixture. We could pass in several cases, but that's for larger program. For this kind of coding exercise, we don't need that. So let's say we are done. But let's integrate our generator class to our program, to our console program. So let's remove this console line and then create a generator instance here, and then get in the results by calling generate and then iterating the results that count, and then console write line each item. We could also do this using for each, but this will do. Let's exit the .NET Watch and then try to run this using the .NET Core Launcher. Since we already covered the code with tests, we wrote the test first. We know confidently that our code works, as we can see here. So 1, 2 is not multiple of 3, not multiple of 5. So it's just printed as normal, and then 3 is Fizz. 4. We could go on and then inspect all of these, and we can be sure that it's correct. 45 should be FizzBuzz. Yeah. Okay, so that's it. While we're here, let's use for each instead, which is a bit more compact. Which would give us the same thing. We could implement this using arrays, but just to implement it differently this time, we use a list, the iList. Okay, so that's it. So in this small coding exercise using FizzBuzz in C# and with TDD, we were able to code FizzBuzz with confidence. knowing for sure that our code works. And if we are able to do this on small programs such as this, we could do this on larger programs as well. So what we have here, the structure of the setup we did is useful for other projects as well in .NET. And in other language also, they are structured similarly. So until next time, we will do another coding exercise, probably on different language. So be sure to subscribe to my channel.